All right, so let's go ahead and get started with our lesson. In this case, guys, we are doing talking more about exponential expressions. In this case, we're focused on word problems. A few keywords in this case that we're going to go ahead and be talking about is the initial value. In this case, initial value talks about basically our starting point depending on what we're given. Most of the time, we're talking about investments or a certain amount of products. That's how much we're starting off with. That's going to be representing the initial value. Whenever it comes to the common ratio, most of the time this here is represented as a percent. I want to say most of the time because other times it's actually converted into a decimal. Converted into decimal. So you're actually going to be seeing both scenarios in this case where you do have a percent, you do have a decimal. So we're going to be seeing both of them. Now, I am writing in this case exponential function because that's what we're working with. Now, in an exponential function, you do have a y. And with an exponential function, you are going to be multiplying your initial value by your common ratio. Now, in this case, when it comes to the common ratio, it really depends what you're actually going to be multiplying by, what the exact value is going to be. Common ratio in this case, and the common ratio is raised by a certain variable, in this case that being x. Now, I do say in this case that the common ratio is going to be different. Just because when it comes to being a percent, let's say they're giving you a certain percent in this case. I don't know, we're saying 30% of the company in this case is decreasing. Let's say it's decreasing, which means that from the original 100%, we're actually taking away 30. So this in reality, or our common ratio here, would actually be that 70%. Now, if I were to be expressing this as a decimal, if I change 100 into a decimal, that's actually going to become 1. And if I change 30% to a decimal, that's going to be becoming 0.3. And if we subtract that, that's actually 0.7, which is 70% as a decimal. So if you're given a percentage in this case, guys, we're basically converting that in this case that percentage into a decimal, and we're subtracting it or either adding it by 1 depending on what they're telling you. In this case, it's a decrease, so we subtract. If it would have been an increase, I would add. So this common ratio does vary depending on if you're given a percent, you do have to do that conversion. And if you're given a decimal, then you're already all set. You don't have to do much work here, just do basic substitution. So let's go ahead and start off with the first example in this case. And I actually want to go ahead and identify some of the key features in this case of the function. So I do have in this case our equation of h of n equals 1 over 4 times 2 to the n. Now, starting off in this case, if I want to go ahead and determine what my first term is, or my initial value, let's go ahead and say initial value, not first term. We actually have to make our variable, in this case, we'll say n, has to be equal to 0. Now, if we do that basic substitution, I have h of 0 equals 1 over 4 times 2 to the 0 power. Now, if I actually input this in the calculator, anything you raise to the 0 power is actually going to give you a 1. And let's just go ahead and check once again, guys. Anything you raise to the 0 power will be a 1. So if I raise the 2 to 0, it is going to be becoming a 1. So then that becomes 1 over 4 times a 1, where in this case, that's actually just going to be 1/4, right? This becomes... Let me do it a different color. That becomes a 1. That part there becomes, this here becomes a 1. All right. So in this case, our initial value in this case is going to be that 1/4. And we are given that initial value here. So this one here is the initial value. That's our initial value. Now, if we take a look in this case at the 2, what that's actually representing is, let's say if I want to go ahead and find h of 1, let's do it in a different color. Let's say I want to go ahead and find h of 1. And I have to do 1/4 times 2 to the 1, which is just 2. And then if I want to go ahead and find h of 2, then I have to do 1/4 times 2 to the 2nd. And notice in this case, this number here keeps on just multiplying by itself, right? If I do h of 3, that's going to become 1/4 times 2 to the 3rd. So it just keeps on increasing and increasing. So in this case, the 2 is representing our common ratio. So I'm going to go ahead and draw an arrow down here. We're going to say that that is a common ratio. Now, another way to distinguish it in this case, the common ratio is always the one that carries the variable. So if you do see in this case a number that's being carried or is carrying a variable in this case, that is going to be our common ratio. All right. So taking a look at this one in this case, go ahead and identify your initial value or initial value and your common ratio. That's something for you guys to do. Go ahead and do your initial value and common ratio. All right, let's go ahead and move on to this next one. And in this case, we're actually focused on writing an equation through the word problem. So in this example, it says that there are 170 deers on a reservation. It says the deer population is increasing. So let me just highlight some things. There's 170 deers. Forgot an S there. They're increasing at a rate of 30% per year. It says write a function that gives the deer population P of T on the reservation T years from now. So we have to write a function P of T, and where T in this case is representing the years. So starting off in this case, our initial value, the first thing I want to go ahead and identify initial value is how much are we starting off with? And in this case, we're actually starting off with 170 deers. That's the population that is found in the reservation. That's how much we're starting off with. And now let's go ahead and actually identify our common value. That's the next one. Let's go ahead and identify the common value. Now, notice in this case, it says that it is increasing by 30% each year, which means that this 100%, which is that 170 deers, it's going to be increasing 30% of that. That's how much more we're going to be adding each year. So in this case, for the common ratio, we actually have to basically do that 100, how I did at the beginning, that 100%, which is representing, once again, this 170 deers. And we're going to go ahead and add that to that 30%, right? Now, if we add that, we actually get 130%. Now, because we are creating an equation, we do want to go ahead and convert this into a decimal. And recall in this case, guys, there's always a decimal at the end of this percent. So if I want to go ahead and change it to a decimal, let's go ahead and move that 2 spaces to the left. And that actually becomes 1.3. I could do 1.30, but I'm just going to keep it as 1.3. Now, once again, guys, another way I did show this is that whatever we have, or whenever we have a percent, we're either going to be adding or subtracting that percent turned into a decimal. So in this case, I have 1, because once again, if I change the 100% to a decimal, that's actually going to become just 1. Plus, if I change this one here into a decimal, that's going to become 0.3. If we add them, that gives us that 1.3. So in this case, our common ratio, I forgot to finish writing there. Common ratio here is going to be that 1.3. So common ratio here, let me move it a bit to the side. And let's move this part a bit. That common ratio is going to be 1.3. So that's by how much it's increasing each year. So let's go ahead and build our equation. Once again, they're telling us P of T. So I have P of T equals our initial value, which is 170 deers, times that rate of increase to the T.